Today, we will take a look into the phase shift of trigonometric functions. Now, the main idea here is that we can move the graph of a trigonometric functions in four directions. Either we can move it up or down, which we're going to call that a vertical shift, or we can move it left or right, which we're going to call that a horizontal shift. Now, here I'm going to use the word shift, which you can think about it as just some kind of a movement. We can have four kinds of movements because we are talking on a two-dimensional plane, either up or down, which we're going to call that vertical shift, or left or right, which we're going to call that a horizontal shift. All right, let's get started. Let's see first. Well, this is just one thing to remember. Remember that when we're talking about a sine function, if you were to just graph y equals sine of x, you would get a graph like this, which starts at 0, and it has a full cycle on 2 pi's, where, in the other case, if we were to graph y equals cosine of x, you will not start at 0, but you will start at the amplitude, which is 1, and you will get a full cycle at 2 pi's. So this is something that we have discussed before. So now the question is, is there a way for us to get the same graph, but just to push this graph either up or down, or either push this whole graph right or left? That's the idea that we're going to try to discuss here today. And the same goes for the cosine function. Is there a way for us to push the graph or down, left or right? Yes, there is, and that's what we're going to talk about today. So first, let's start with something that we're going to call a vertical shift. Okay, so there's one way for us to move the graph up or down, because remember, vertical, it's either up or down. Okay, so if we add a number outside of the trigonometric function, we're going to be moving the graph upwards. So by adding outside, we move the graph upwards. And by subtracting outside, we move the graph downwards. So by adding, we move it up, and by subtracting, we move it down. But note that the vertical shift always happens outside of the function, always. So if you see a number being added outside, that's an indicator that you're moving up or down. If the number is being added, then we're moving it upwards. If the number is being subtracted, then we're moving it downwards. So let's see how does this look like? Well, let's see some examples here. Well, example 1, it says graph the following functions. You can easily just get this function, put it in the calculator, you get a graph, and that's it. But that's not exactly what we want to do here. So the first thing that you want to do is to graph what we have, what we're going to call the parent function here, where the parent function is the functions that you know so far, either sine of x or cosine of x. Notice that in this case, we're going to talk about sine of x. So if we remember, and if we take a look at here, if we graph sine of x, it starts at 0, and it takes 2 pi's to complete a cycle. So let me just graph that. So it starts at 0. Let me actually sine of x. Let me just do it in red. So we got 0, we got up, we got pi, we got 1, and we got 2 pi. All right, if we were to graph just sine of x, this red graph, it's an illustration of the function y equals sine of x. Okay. So the red one is y equals sine of x, but this is not what we wanted to graph. What we wanted to graph is sine of x plus 3. But we know that if sine of x looks like this, the moment that I add 3 outside, because of this 3 outside here, then we're going to have a vertical movement, and we're going to move the graph 3 units up. Because remember, if we add in a number outside of the function, we move it upwards. So this is the function. If we would put it inside the parentheses, that would be inside. We're adding outside, so we move it upwards. So what do? You get the points that we have from sine of x, and you just move it 3 units up. So this point is the sine of x. If I want to graph sine of x plus 3, just move it up 3 units. 1, 2, 3, and there it is. You get this point, move it 3 units up. 1, 2, 3, and there it is. You get this point, 3 up. 1, 2, 3, there it is. You get this point, 3 up, so that's 1, 2, 3. Then you get this point and you move it up. 1, 2, 3. All right. So let's just connect the dots here. So what we have here in blue, this is the graph for y equals, let me write that again. So this is the graph of y equals sine of x plus 3. So notice that first you graph the parent function, and then you look as to, well, where am I adding or subtracting? And that's going to give you an indicator as to how you're going to move it. So now let's look into again here. So now, let's see, cosine of x minus 3. Well, the first thing that I want to do is to write down how does cosine of x look like without the minus 3. So for that, remember that the cosine of x looks like this. It starts at the amplitude, and it takes 2 pi to complete a full cycle. So let me just do that here. So it starts at the amplitude, then 0, then minus 1, and 0, and right here. Okay? Let me just put some arrows to indicate that it just follows. So what we have here in red is cosine of x. So this is just regular cosine of x. But this is not what we want to graph. We want to graph cosine of x minus 3. But because of this minus 3, we're going to move the graph 3 units. But this case is 3 units down. So let's keep that in mind. So what we're going to do, we're going to get every single point here, and we're going to move it 3 units down. So we're here, 1, 2, 3. There we have it. You get the original point, 1, 2, 3, and there you have it. You get the original point, 1, 2, 3. There you go. Original, 1, 2, 3. There you go. You get the original, 1, 2, 3. And there you go. So you're going to get that same shape as we had it in the blue, but the only difference is that it's moved downwards 3 units. So this is the cosine of x minus 3. And this is exactly what we wanted to graph here. All right, so now let's take a look into, well, here it is again. Just remember this, that the sine looks like this and the cosine looks like this. But here is the most interesting part here. Now, for the horizontal shift, it's a little bit different. Because now, for the horizontal shift, if we're adding a number inside, you might think that you're gonna be moving to the right, but no. When it comes to horizontal shift, it's pretty much, you're gonna go against your intuition here, because if we add a number inside, the function will actually move to the left side here, and vice versa. If we're subtracting a number inside, your function will be moving to the right. So this is something that students sometimes get confused because you think that if you add in, well, you move to the right, but because the positive numbers are on the right side on the number line. But no, in this case, if you're adding inside the function, you're going to move your graph to the left side. And if you're subtracting, you're going to move it to the right side. So when it comes to horizontal shift, if you add, you're going to be moving to the left side. And if you subtract, you're going to be moving to the right side. So in the next examples here, I already draw how the sine function and the cosine function looks like. So let's actually see how does this plus pi affect the original. Because notice that if I block this plus pi, that's exactly the graph that we have. Because we got with this graph is for sine of x. But what happens to the function when I add pi over 3? I'm sorry, when you just add pi? Well, notice that you're adding a pi over 3 inside, and according to the horizontal shift, if you're adding inside, which you are, you're gonna be moving your function to the left. So here, we're adding a pi, so this is an indicator that you're gonna move pi units. So you're gonna move pi units to the left. So this is the original, y equals sine of x. So if we want to graph sine of x plus pi, all we gotta do is just, you get the point from sine of x, and you're gonna move it a whole pi units. So you're gonna move it 2 squares here, because notice that here, 2 squares is 1 pi, so you're gonna get here, you move it 2. So that becomes here, because we get this point and we push it pi units to the left. You get this point, you push it pi to the left, you get this point, you push it pi to the left, you get this point, you push it pi to the left, and you get this point, and you push it pi to the left. So what we have here in blue is the function sine of x plus pi. So now let's take a look as to what happens when you subtract a pi. Well, again, here in red, we have the cosine function, which is a parent function. So that's no biggie. So the idea here is what happens to this graph when you subtract a pi inside of the cosine function. Well, notice that if you subtract inside, you actually move your graph to the right side. So we're right here, we're subtracting a pi. So this is an indicator that you're going to be moving pi units, but this time to the right, because of this minus pi. So we're going to get the parent function. We're here, and we're going to move it pi units to the right. So pi units to the right. We get this function, pi units to the right. We get this point, pi units to the right. We get this point. It's going to be somewhere around here. So pi units to the right. All right. So now that you have this, all we got to do is just connect those points. All right. So what we have here in blue, this is the function cosine of x minus pi, y equals, which is exactly what we wanted to graph here. So now, here's your entrance ticket. Graph the following function.